Okay, Assalamualaikum and hello everyone. So today we are going to present our report experiment 5, which is bending moment. Okay, next video. So this is a name of student in our group, which is Lim Zihui, Muhammad Yusuf bin Omar, Saifullah, and lastly Hafiz Nur Izzuddin bin Jimat. So this is a table of contents that we are going to introduce all the lists in our experiment, which is introduction, objective, theory, working principle, experiment setup, methodology, safety procedures, result and discussion, references, and last was a conclusion.
Okay, so for introduction, for this experiment, bending moment is the study of internal force that occur to the element to be bent. Bending moment at the beam is calculated as the algebraic sum of all force at each side which occur at the beam, RA, RB, P1, P2, and P3. Next.
So for the objective, in our experiments, we measure the bending moment of material when subjected to different loads at different distance. So the scope that we use in our experiment to achieve the objective, that we use distance between A and B is 900 millimeter. Load used in the experiment start from 0, 1 Newton, 5 Newton, 10 Newton, and last 15 Newton, and last was 20 Newton for each load hanger. Lastly, we use the distance between fixed hanger and other hanger from 200 millimeter to 300 millimeter.
Okay, so moving to the theory and working principle, bending moment occurs when a force is applied at a given distance away from a point of reference, causing a bending effect. In the most simple terms, a bending moment is basically a force that causes something to bend. So if you look at the diagram below, so this is a beam, and then if we place a load here, meaning that we putting the external force here. So it will causing the beam to bend and create a bending moment at the sections C. Next slide. So this is roughly, here is the C part, which is the bending part, and then P1, P2, P3 is the place that we put the load hanger, and then RA and RB is the fixed support. Next slide. So how we calculate the bending moment? So bending moment is a force normally measure a force multiplied by length. So the distance must be perpendicular from the force, and moment is force multiplied by distance, and bending moment is said to be positive moment at the sections when it is acting in an anti-clockwise, and negative moment when acting in a clockwise directions. So bending moment at sections is defined as the algebraic sum of the moment about the sections of all the vertical force acting on the pin, either to the left or to the right of the sections. And how we calculate the experimental bending moment is that we taking the value of the force from the spring balance. So for the we take the initial value without putting any load on the load hanger to get our F1, and then for getting F2, after we getting the load, only we read the spring balance and we multiply by the perpendicular distance, which is 150 millimeter.
So for experimental setup at this experiment, Next, okay, we have load 1 Newton, 5 Newton, and 10 Newton. Other than that, we have magnetic water pass. Next, we have a measure tape. And lastly, we have experimental beam and load hanger.
Okay, let me explain about the methodology. This is the part one. First, we need to have a beam, a set of beam. A beam is connected with fixed joint and divided into two parts, which is A and B. And the second is the distance between point A and point B is 90-100 millimeter, and every scale line is 50 millimeter. So the third step is the spring balance is attached to the beam to calculate the force applied. As you can see, the spring balance placed at the P1, P2. Then set up all the apparatus as shown in the diagram. So after that, set the distance of P1 200 millimeter from P2, and P3 300 millimeter from P2 respectively. Next, make sure the beam realign by using the adjustment at the spring balance, and we need to make sure when we adjust the spring balance, we need to make sure that the bubble in the water pass at the center. Then we record the initial value of the spring balance. After we record the initial value, so we put 5 Newton of load at P1. After we put, then we need to realign the beam and record the reading. After that, we need to remove the load. So we need to repeat the step at hanger P2 and hanger P3. After all the step 8 and step 9 done, we need to repeat this experiment with 10 Newton and 15 Newton and 20 Newton. So actually at part 1, we used to make the different distance, which is we can get 200 and 300 but constant load. But in part 2, we have a constant distance but have a different load. So just use step 1 until 4 as the same as the part 2, and then we continue with at part 2 in this part 2 we continue with step number 5, which is set the distance of P1 200 meter from P2 and P3. We need to set the distance P1 200 from P2 and P3 200 from P2 respectively. So step 6, we need to make sure the beam realign by using the adjustment at the spring balance and the bubble in the water pass at the center. Then we need to record the initial value. Next, put 0 Newton load at P1, 5 Newton at P2, and 10 Newton at P3. Then we need to align again the beam and record the reading. After that, remove all the load. So after we have done with the first one, we need to repeat this experiment by using different weight of load, but based on the given table in this slide, as you can see. So for the part 1, for the calculation, this is one of the example. For the experimental calculations, we know that the submission of moment C equal to net force multiplied by 100 millimeter, which is the distance on the spring balance. And then we have the theoretical calculation. First, we need to calculate the moment at B. As you can see, submission of moment B equal to RA, 100 millimeter, which is the distance between A and B, minus with P1, the first hanger, which is the distance between B and P1 equal to 100 millimeter, at 100 millimeter equal to 0. Then after we get the RE, so we can find the moment C, which is moment C theoretical equal to RA 300, which is A to C 300 millimeter, minus with P1 200 millimeter. For the calculation at part 2, experimental calculations, as usually, sounds like the first part, which is submission of moment C equal to net force multiplied by 150 millimeter. For the theoretical calculation, this is slightly different from the part 1. As you can see, the submission of moment B equal to RA 100 millimeter, the distance, P minus P1, uh, and, and P1 100 millimeter minus P2 600 millimeter and minus P3 400 millimeter equal to 0. Then after we get the RA value, so we can find the moment theoretical, which is RA 300 millimeter minus P1 200 millimeter. So this is the result and the theoretical calculation that we get after the experiment. As you can see, we have lots experimental bending moment and theoretical bending moment, and the percentage error. And this is the part 2. We use the different lot, but the constant distance between the hanger. So about the discussion, when the lot was double in part 1 of experiment, did the bending moment double? Based on what we have done during the experiment, we can say this is true, because as at P1, when the load at 5 Newton, the bending moment is 300 Newton millimeter, while at 10 Newton, the bending moment is 750 Newton millimeter. So the value of the bending moment at 10 Newton slightly higher than the doubling when we doubling the value of 5 Newton. This might there some errors during our experiment. But we can assume the value of the bending moment can be double. As a conclusion, when the value of the load double, so the bending moment also double, even at the different position. As you can see, let's say on this graph, at the red bar, you can see the value. You can see the value seems like doubling, and also when you see the blue bar, also it seems like double. The value is double. So the other question is compare the average figure for each of the experiment by using the bending moment value obtained from the experimental, and theoretical is either the ratio of the percentage. So in this experiment, we use this formula: theoretical value minus experimental value over theoretical value. We multiply with 100%, so we gonna get the value in the percentage. So this is how we calculate the percentage error between the theoretical and experimental value for the bending moment. So in this experiment also, there is a variance of range from 0 to 20 between the experimental and the theoretical value of the bending moment. All of the value actually at the normal range, which is 0 until 50%. But in this experiment, we notice that at P3 with 5 Newton, the percentage error is 20%. This is we have during the experiment, we might have some error, which is parallax error. When we get reading on the spring balance, other than that, the spring balance was not sensitive to small change in the weight when we put the load on the hanger. So the other error might be occur when we try to change the load, but the hanger is moving to some distance.
So this is a safety procedure that we need to comply with. We are conducting the experiment in a lab. First, we need to make sure that we wear the proper PPE, which is a lab coat and safety shoes, which is very compulsory to enter the lab. Next. So this is a precautionary steps that we need to follow while conducting the experiment, which is we need to check the water pass, which is we need to check before we use it in our experiments. Make sure it's in a good condition. Ensure that the vials are clean and free from the debris that could affect the accuracy of the reading. Second, we need to select a level surface, which is we need to place the water pass on the surface that we want to check for levelness. This could be a beam that we use in experiment. Third one is position the water pass. Just we need to place the water pass on the surface so that it's parallel to the direction that we want to measure. Lastly, while reading the water pass, we need to look at the wire glass, uh, which is the bubble. The goal in the water pass level is to center the bubble between the two lines and inside the vial. These lines indicate the level or plumb position. This is a load that we use in our experiment that we need to make sure that we handle it carefully while conducting the experiment to prevent any injury.
Okay, so moving to the conclusion, we can say that our experimental result is highly accurate because it's almost very slightly the same value with the theoretical value. Although we have slight deviations between the experimental value and the theoretical value, the result is quite accurate, and it is almost the range of error percentage is almost 0% to 20%. So these percentage are probably can be neglected. Anyway, the highest percentage error is because of errors that occurs during the experiment. So we also found that in this experiment, more load position at a certain point, especially at P2 of the beam, will actually increase more the bending moment value at the same point as well. So thus the theory is proven to be true. Next. So this is our reference to do our report, and thank you.